Hi and hello everyone. Welcome to the series of tutorial on milestones in Python 3.8 with exciting new features. This is your presenter and facilitator Kamal Raza, and this video is specially about maths function in Python 3.8. There are a couple of maths functions that have been released in Python 3.8 that would like to discuss and give you an idea of how these could be useful and how you can use it, what could be their applications, and if you know about it, you'll be able to use it in your codes, and definitely it will make your work easy and quick. So let's begin. In this tutorial, I'll be discussing I square root that product distribution function and hypotenuse function. So these are the four functions. Out of these four functions, earlier we have already discussed I square root function, but let's give a small overview of that. Now the I square root function is actually this integer square root function, and whatever number we pass through this function, we get an integer value. So let's see this. First of all, let's check the Python version. Okay, so the Python version that I'm currently using is 3.8.1. Okay, let's go into Python and import the maths library. Okay, it's imported. So math.isqrt, and let's pass here 7. Now we know that for 7 the square root would be somewhere like 2 into 2 gives 4, so the square root of 4 is going to be 2, and 3 into 3 gives 9, so square root of 3 is square root of 9 is going to be 3. Here this is between 4 and 9, this is somewhere 7, so it is going to be like somewhere 2.6 or 2.7, something like that. But since this function that we are using is an integer square root function, so it should give the value in integer. Let's check out. So it's giving 2. Now, when we do the same thing with the square root function, we're getting 2.64. That was expected. So it's giving a float value. But I square root always gives the value in the form of integer, and that the square root is just a number below. Or for example, it just round down the number. Now math.product. This is similar to math, actually the sum function that we generally uses. For example, when we do 2 into 3 into 5 and 2 again, so 2 into 3 gives 6, 6 into 5 gives 30, 30 into 2 gives 60. So that's the answer. But when we use this with product, okay, 2 into 3 into 5 into 2, we can get the 60. So this here we can pass on an iterable. The iterable could be a list of numbers, and we get the answer in the form of product. This is especially useful when for numeric values, and we don't want any non-numeric values in the tuple in a list, so we can use this function to create a product, or maybe to check if the value or the list has any non-integer number. So we can use this function to get an idea. Basically it takes in an iterable and the starting value. For example, let's see this how it works when we don't pass on any value. So we are passing an empty list, so it gives a default value of 1, and this is always the case. But when we give it at least a 1 value, let's do this 3, no, actually 3, and so it gives 3 only. But when there is no values passed, it gives 1. And let's do this with a non integer value. So it gives an error. Name s is not defined. So it actually rejects the value. The other function is the distance function. Now, this function is used to calculate the Eleusian distance between the 2 points. So we already know the formula, and let's apply this. See here, we get the distance. So here we have applied, we've given two lists as two different points, and it calculates the distance between these 2 points. The important thing is that it must have the same dimensions. Let's do this again, and let's pass on 3 dimensions. Again, it calculates, but if we pass on different dimensions between the 2 points, it won't take it. um, so let's try again. Let's see that it has only 2 dimensions, so it is going to give both points must have the same number of dimensions. This is the error. So actually, what distance formula does is calculates the distance between 2 points, and it must require the same dimension. The points must be given as an iterable, for example, as a list, and that we just saw. The last formula that we are going to discuss, or the function that we're going to discuss, is the hypotenuse function. Now, this hypotenuse function was earlier there, but it was only for two-dimensional calculations. Like it was only for a single right angle triangle, calculating distance between the origin and the point, and like in hypotenuse calculation, the distance or the length of the hypotenuse, we generally use Pythagoras theorem, like square root of x square plus y square. So here we can take n number of dimensions. So not only 2 dimensions, we can take n number of dimensions and calculate the distance between the origin and the point using the using the Eleusian formula. Let's see this. Math.hypot. So let's pass on hypotenuse, and I've given three-dimensional values. Okay, I just mistyped it. Okay, it does not require the list, so we have to give. Here it is. So with three-dimensional values, or three values, you can still calculate the hypotenuse. Let's exit this, and I just try to show you import math.hypotenuse. Coordinates are let's see, 3 comma 4 comma 5, and let's get the answer. Python p38 mathstats.py. Okay, we didn't print this, so we have to print it as well. So there it is. We got the answer. I hope you enjoyed it. We discussed a couple of functions that are added in Python 3.8 in the maths library. Now there is another library that is stats, and it has also a couple of new functions added. So if you're looking to learn it, feel free to get in touch with me, and don't forget to rate this um, or subscribe to my channel. You can find it on YouTube. And if you have any queries, you can get in touch with me through email, through YouTube, through um, Udemy, or through Medium. Hope to see you again. Thank you.